Okay, well, welcome everyone. Today's Wilson Forum, we're going to have Michael Garjian speak about sustainable power for a sustainable economy. Michael he's going to talk about using carbon dioxide removal technologies as the main focus of his attention. He is the founder, along with his wife, Irene, of a company called CarbonStar Systems Incorporated. He spent 16 years in the carbon dioxide removal industry, developing the technology, patenting it, and the successful demonstration of CarbonStar. He has a degree in business management from the University of Massachusetts at Amherst. He's a lifelong commercial and social entrepreneur. And Michael, I'm just delighted that you're here today. I like the combination of commercial and social entrepreneurship, because I really do think that's where this nation needs to head. We need to put social science and social interest clear front and center in the kinds of technology we develop. So I'm glad you're here. We're going to hear about your work today. Michael, the floor is all yours.
Well, here we are after weeks of anxiety putting this together. I'm really honored to speak to you all. Thank you, Ron, for inviting me. Hugh, right? Thank you for finding me. I'm here because of Hugh. Hugh found a video, and I'm really happy that he came into my life. And I find it all interesting that we come from so many varied backgrounds. I'm going to be using a PowerPoint today to keep myself on track, because these inventors sometimes can wander a bit. So we're going to try to keep everything organized with a PowerPoint. So I'm going to switch over to that now. Okay, let's see. Here we go. All right. Everybody can see the screen and can hear me.
Yep, you're all set.
Okay, great. So I find it interesting that we come from so many varied backgrounds. As a farm boy turned inventor, I came from a different space. I grew up on a chicken farm with 40,000 chickens, and my hope was to become an inventor. Like Ron, who credits a teacher with his becoming an engineer rather than a coal miner, I credit a teacher with helping me become an engineer and scientist of sorts, and I became an inventor. So today I'm going to be discussing how we plan to use the CarbonStar system, a carbon dioxide removal technology I invented to help create sustainable economic communities. So let's see if I push this. Okay, I guess I have to do that. So we're at a time in history where it's essential to think about climate change really seriously. The March 20th, that was last Monday, final warning from the IPCC tells us the window for a livable, sustainable future is rapidly closing. Time for lip service is over. Any honest and realistic approach to address climate change demands that we identify and evaluate all significant contributing factors, including the current economic system itself. In evaluating the dominant system of corporate capitalism, we must think beyond the next quarter or the next year. We must think in terms of decades and even centuries. Will we survive as a society 200 years from now? We need to be thinking about that now. Globally, calls are increasing for a sustainable economic system that will better serve the commercial and social sector while addressing our socioeconomic and environmental challenges. The quest for long-term planetary survival and sustainability also demands that we remove our legacy atmospheric CO2, as discussed here by Hugh Wright a year ago. Many now accept Hugh's assertion that we must remove 600 to 1,000 gigatons, that's trillion tons, of CO2 within the next century to avert an environmental and anthropological disaster. Young and old, we must all pitch in. My own efforts are focused in two technological areas. Since 2000, my technological work involved assisting in the development of vegetable-based fuel systems, and most recently, the CarbonStar mobile catalytic vacuum pyrolysis system. to remove carbon dioxide from the atmosphere. My work in economics relates to the development and testing of E2M, an economic model from Millennium 2000, which envisions a network of sustainable, decentralized community economies. Many are now calling for change in the status quo. The phases of change can result in some anxiety as we cope with the loss of the past and uncertainty of the future. Newfound hope, joy for newfound hope, and a measure of increased stress through the process of change. To help cope with change, I want to consider the words of Marx. He said, when I think of Marx, I think of the word smile. And we all know life is challenging, and change adds to our challenges. So it's important to never lose our sense of humor. It will help us in trying times, and there are trying times coming. When I think of Lenin, the word I think of is imagine. So I'm going to ask you to imagine. Let's imagine if we could use sustainable power to help create sustainable community economies where communities are as powerful as corporations, people are as valued as profits, and our environment is improving. Now, without a degree in economics, my discourse on that subject draws from my life experiences. Some of this material may even seem utopian. So a quick review of those experiences might be in order. In the 3 decades before the turn of the millennium, I was a commercial entrepreneur who developed products and technologies and sold them around the world. During that time, I employed almost 450 people, was granted 10 worldwide patents, established 5 manufacturing facilities in the US and 1 in South Australia, sold millions of dollars of products, and entered a corporate joint venture with what was, in 1992, the largest company in the world. In 1974, I became fascinated by the work of Nikola Tesla. In 1985, following years of R&D inspired by Tesla's ideas, I started Neon Technology to manufacture light-emitting plates of glass with decades-long lifespans, which I had invented and patented internationally. The light was emitted from plasma streams I encapsulated within the flat plates of glass. Market conditions did not support the technology, so I pivoted to engraving artistic images and logos within the glass plates and filling those images with neon or other rare inert gases. I took the trade name of plate glass neon. Today's traditional neon signs are fabricated using glass, plasma-filled bent tubes to create illuminated images as invented by Georges Claude in Paris in 1912. Plate glass neon eliminated the need for the fragile tubes and produced glowing images from the plasma streams infused within the engraved plates of glass. This is what a traditional neon sign looked like back in 1985, as well as today. They haven't changed since 1912, except for my technology of plate glass neon. This is a 12-inch square neon sign fabricated using my process. So we've engraved the images within plates of glass, and these are neon, glowing plasma streams of neon. Plate glass neon signs were acclaimed by the major industry journal as the most significant advance in neon sign fabrication since the invention of neon signs in 1912. We produced thousands of neon signs for such companies as General Motors, Guinness, Coca-Cola, Pepsi, Budweiser, Adidas, Zildjian Symbols, Ford Motor Company, Dr. Pepper, and others. In May of 1998, however, the Asian economy began collapsing as investors moved billions of previous investment dollars from Asia back to the US, where returns were higher. The NTC joint venture could not survive the collapse, and no one was interested in investing in a manufacturing operation in the midst of the 1998-99 dot-com fervor and eventual debacle. On August 30th of 1999, after securing employment for all of my employees, I closed the company. Of the thousands of signs produced by that company, the most important to me was a plaque presented to me by my employees for my contribution to science and technology and my dedication to my employees. I look at my employees as my family and my children. I then took a position as the Director of Small Business Development at the Valley Community Development Corporation. Now, that was my first job in 35 years. My job was to help very low and very low income residents of Hampshire County start small businesses. During the next 4 years, my office helped launch 70 businesses, lent them close to $500,000, and created more than 100 jobs. These are some of the newspaper articles about my work and my clients. And these are a picture of some of their businesses that we started. I also work with the Anti-Displacement Project. It's a group of 8,000 residents living in 5 apartment complexes, representing 1,450 families. The complexes represented over $40 million in economic assets and $6 million in annual cash flows, and are directed by 5 tenant-occupied and controlled boards of directors. I taught the boards of the complexes how to understand complicated financial reports and help them to understand how to use their economic power to achieve their social goals. I also helped them launch and administer United Landscaping, a worker-owned cooperative composed of tenants from these complexes that provided services to them. And I wrote a business plan and helped them secure $175,000 in loans. In 2003, I was awarded an ADP Champion of the Year for my work. And this is a group of us. I took this picture. We'd gone to the Senate office building, came in the front door to go up to see Senator Kerry and Senator Kennedy's people. And the elevator operator said, I'm going to have to separate you all into 3 elevators to get up. And they said, oh no, we came in as one. We're going to go up as one. So thank you anyway. We'll take the stairs. So he took a bit of pity on us and said, follow me, and took us back. And so he put us into the Senate freight elevator. So this is the group heading up to the Senate offices in a freight elevator. It was one of the best times of my life. I also worked with a Century Care Alliance. My job was to help refugees and other new Americans in small business startups. I worked with a number of their clients and raised $250,000 in small business funding for the organization. These are 2 of my clients featured on the front page of Business West magazine. This is Google and Mina, and we were helping them with their food business. So enough of me. Let's get to the real story here. At this time in history, we need to urgently address climate change and understand that it provides an opportunity for us to use our emerging technologies to help establish sustainable community economies. Let's talk about how we could use that sustainable energy to help establish such economic entities. To avoid severe climate change, we must remove 1 trillion tons of atmospheric CO2 during the next 70 years. General consensus is that this will give birth to a new $100 trillion CDR, carbon dioxide removal industry, and trillions more in economic impact. How could this new wealth be used to create sustainable community economies to serve the common good, rather than just falling into the same hands and the same group of elites that are creating the economic problems we have today? It is important that this massive effort to remove CO2 benefit the community at large, economically as well as environmentally. Unless all stakeholders benefit, long-term sustainability will not be possible. Sustainability is essential to long-term human survival. So what are the critical components of a sustainable planet and communities? Well, we all know renewable clean energy is one. And the second, in my way of thinking, is to create sustainable regional economies linked within a sustainable global economy. Let's discuss both. CarbonStar catalytic vacuum pyrolysis system is a carbon negative source of energy that uses any form of biomass to produce biochar, biofuels, and soil amendments while permanently sequestering significant amounts of atmospheric CO2 for millennia. CarbonStar is my development after 16 years in the biochar world and many more in renewable energy. CarbonStar Systems, Inc. is a mass domestic benefit corporation, a B Corp. As a B Corp, it must certify community and ESG agendas. 10% of CarbonStar's equity is set aside for community ownership. CarbonStar holds US patent rights to the CarbonStar technology that I developed. It is also a Carbon XPRIZE qualified team, ranked in the top 80 of 1,300 global entrants in the first judging of the ongoing $100 million Carbon XPRIZE. And we're going to share our CDR subsidies, royalties, and or profits with local communities and employees to address our socioeconomic challenges. It all began in 2008 when I licensed E3 LLC, a company formed and owned by my investor and me, to develop and commercialize the CarbonStar technology in the New England region. Development began with a model. This is that model that I built. Starting point was when the vacuum tube arrived. To keep my promise to my investors to start building the system before year's end, I raised the vacuum tube on stands at 11:29 p.m. on December 31st of 2018. I kept my promise with 30 minutes to spare. I then left the shop and returned to the hospital where my wife was a patient to celebrate the new year with her. We then evolved and continued with the addition of airlocks, band heaters, then the vacuum pump, process tanks, unistrut supporters for piping, power lines, and sensors. I installed 31 sensors that record and monitor cycle times, temperatures, vacuum levels, pressures, rotational speeds, and all of these sensors were connected to the brain of the system, completely computer operated. These enable us to control every aspect of the pyrolysis process, including biomass residence time in the reactor, pyrolysis temperatures, and vacuum levels. These are the three most important factors that determine biochar consistency and quality. No other production system that I know of can achieve this level of control. This is what the system looks like, completed in May of 2021 after some COVID delays. The way the system works is feedstock comes up through this auger, fills this chamber. When this chamber reaches a certain level determined by this switch, the airlock opens, this gate opens, drops the biomass into this chamber, this gate closes, this gate opens and drops the biomass into the vacuum tube. We can hold vacuums up to 25 inches of mercury in this tube using this 40-horse vacuum pump. Inside the tube is a screw, a conveyor screw, which pulls the biochar, the biomass, down through the tube using this motor. The tube is lined with heating elements, and we can control the exact heat along the entire length of the tube. As the biomass moves through increasing levels of heat, we get into a depolymerization reaction where long-chain cellulose and lignin and hemicellulose molecules, hydrocarbon chains, are broken from long-chain hydrocarbons into short-chain hydrocarbons. Those hydrocarbons, short-chain hydrocarbons, begin with CH4, that's methane, then ethane, then propane, then butane, and working our way up to C11. But at this stage, we begin to go exothermic because as we're depolymerizing the biochar, the biomass, we produce energy when we break those carbon bonds. So we continue to move through the system. And at this point in the system, everything is depolymerized. All of the volatiles are depolymerized, and the solids drop out through this airlock down here, and those solids are what's called biochar. The vapors, there's nothing solid, nothing liquid left in this system. The vapors then travel up through this exit nozzle through a cleaning system, and they're clean. It's the final system, and this part of it is the most advanced system available. This picture is of the catalytic vacuum tube side of the system. Once the vapors pass out of the tube, we go into the condensation portion of the system where the vapors are cooled to condense into biofuels. This tank here contains a heavier fraction similar to diesel 6 or bunker oil. So this is a heavier biofuel. This tank is a lighter biofuel. This is where we get our bioheating oils, biokerosene, biojet fuels, and biodiesel number 2. These are light fractions. We're able to control which fractions we produce by controlling the temperatures of these tanks. We also produce wood vinegar, an organic substance used in varying concentrations to act as a foliar spray to increase photosynthesis efficiency, as an herbicide or a pesticide. The types of biomass feedstock we have tested may include wood chips from forest waste, agricultural waste, water treatment plant waste, municipal solid waste, sugarcane bagasse, palm waste, giant reed, and seaweed. Seaweed is very interesting to me. We can use seaweed. Well, let me talk about quickly how the biochar pulls carbon from the atmosphere. The biomass absorbs CO2 and gives off oxygen, keeping the carbon. So a tree keeps that carbon. It's 40 to 50% carbon. Normally, the tree would die, and the biological decay process would return its carbon to the atmosphere as CO2, or in the event the tree falls in water or another anaerobic area, it'll return it as methane. So this is the natural carbon cycle. Biomass absorbs CO2, gives off oxygen, dies, and returns the carbon back to the atmosphere. And of course, we've interfered with that by taking stored, inventoried carbon from oils and coal and introduce those into the atmosphere. So this is how we decarbonize the atmosphere. Now, seaweed will decarbonize the ocean, which is in worse condition than the atmosphere. You don't hear so much about it because we don't breathe water. Giant reed, on another type of biomass, grows anywhere on the planet where vegetation grows and can provide 28 tons of dry biomass per acre. Giant reed and seaweed are short-term biomass, so we maximize carbon dioxide removal. You don't have to wait 20 years for the next plant to grow. It's a cycle that occurs every 90 days, so we can sequester massive amounts of carbon dioxide with not only wood, but especially giant reed and sargassum. And if you read the newspaper lately, you can see that sargassum is becoming a huge problem in Florida, already in the Bahamas, Mexican coast, and it's going to get worse as a 5,000-mile wide blob of it begins to come into the land mass in July of this year. So using these substances, this allows us to produce energy virtually anywhere on the planet where we can grow biomass. Thus, we can create off-grid communities, develop resilient, decentralized electrical grids and microgrids in remote areas. Biofuel crops can be grown in partnership with struggling farmers in Massachusetts to provide them with additional income without using arable lands now producing food. Massachusetts has hundreds of thousands of acres of fallow land, protected lands, median strips, and other protected lands to grow energy crops. In fact, it's more than 1 million acres. So CarbonStar sequesters CO2, as I just described, by carbonizing decaying biomass, which emits 17 times more CO2 and methane annually than all human activity. So decomposing biomass produces 17 times more CO2 than all human activity. We do this by producing biochar, bio-oils, and biogas. Our computer-controlled systems allow us to control residence time, temperatures to 1200 degrees Fahrenheit, vacuum levels from 5 to 20 millimeters of mercury. This is a dual function system. We can use it as a pyrolyzer to also produce oils and gases, or we can use it as a gasifier to convert the biomass directly into gases. This enables the production of standardized and repeatable outputs. Now, this is really important because biochar, no two biochars are the same. It's a very quirky substance. So if you do a field test, and academics do a field test, in order for the results of that field test to translate to macroscopic use by farmers, you need to produce and use the same type of biochar you used in your studies and control it. And that's not possible unless you can control the residence time and temperature and vacuum levels. So particularly in using biochar in areas like concrete, you need to have a standardized biochar to avoid buildings collapsing, because the biochar, which can replace 20% of the cement, was not standardized. So this is why it's very important. The system is also the most economical and sophisticated, I believe, in the world. It's self-sustaining. It enables the production of energy anywhere feedstock exists. It's easily verifiable CDR, carbon dioxide removal. This is a big issue in carbon credits now, and why some companies won't buy carbon credits, which are given to those companies that can sequester CO2. The problem is that it's difficult to determine how much CO2 you sequester by, for instance, adding minerals to the ocean or minerals to the earth, or other types of means to indirectly pull CO2. With our system, you simply measure weigh the biochar, measure the percent of carbon, usually that's about 80%, and that tells you exactly how much CO2 you're sequestering. And it's also an economical solution for the decentralization of the grid, which is becoming more and more important, as you probably have read in the paper. And again, this is a true CDR system. We actually do sequester carbon dioxide. Not all biochar sequesters carbon dioxide. And you can determine that by studying the LCA, life cycle analysis. And an LCA says, how much carbon are you introducing into the atmosphere in your process of sequestering carbon dioxide from the atmosphere? So one process to make biochar is put wood into a 55-gallon barrel, seal the barrel, drill some holes into it to let the gases out, throw it into a bigger fire, and as that large fire heats the barrel, it cooks the wood inside to produce biochar, but you're also introducing CO2 into the atmosphere with the fires that you're using to create the biochar. That is not carbon negative. Even worse, a biomass power plant burns 1,200 tons of wood to produce 10 tons of ash, of which 40 to 50% is carbon. So when you do the math on these large technologies, biomass power plants, you end up emitting 266 tons of CO2 to sequester 1 ton of CO2 through the ash. So these things are becoming more studied now, early in a new industry, and biochar is now one of the heavily invested industries, CDR. All types of people are going to come in with all types of claims, but it's really going to turn out to be determined by what is the true life cycle analysis, and we pass muster on that. For every ton of biomass we use, we sequester 1.5 tons of CO2 through the biochar. Now, this is the virtual biochar we produce. This black substance used to be CO2 in the atmosphere. Biochar does a number of things. It's actually a miracle substance. And folks say, don't tell everything that it does because people won't believe it. But here's a few of the things that it does do. It increases the organic content and trace minerals in the soil. You can convert barren to fertile land. You can increase soil microbial activity, increase nitrogen uptake by plants, provides increased surface area in the ground for bacteria to grow. A gram of good biochar will have 300 to 400 meters of surface area in it. A teaspoon is 3 grams. A teaspoon of biochar has about 1,000 meters of surface area, square meters. And all of that is electrically active. That will pull toxic metals from the soil. It'll pull aflatoxins from the soil. And so it's very much like activated charcoal, but much cheaper. It increases the cation exchange rate, which is the rate that ions flow through the soil, which can also increase fertilizer efficiency by 300%, increase water and air retention, increase biomass yields as high as 300%, reduce erosion, increase CO2 absorption by the soil, decrease nitrogen oxide outgassing by the soil, and NOx is 270 times more powerful as a global warming gas than CO2. And it also binds to and deactivates soil-borne aflatoxins, which are becoming a growing problem, particularly in corn. It removes CO2 from the atmosphere, can sequester that carbon for millennia, add it to concrete. It'll reduce the carbon footprint of cement, which is the most highly used substance after water. It can be used as a coal substitute, but that's its lowest use. We don't want to burn it over. And it's exactly the reverse of coal mining. Coal mining, well, we won't go into that. We don't have to do that. We did a test back in 2007 that at Virginia Tech University, they put 4 aflatoxins on the soil and then applied 1 gram per liter of our biochar, 1 gram per liter, 3 grams per liter, and 5 grams per liter. And we were able to efficiently bind and detoxify anywhere from 84%, 82%, and 64% of toxins off of that soil. So that's what the biochar can do, along with more things. And this is the biochar we were selling locally through outlets in Western Massachusetts. And this is a mixture of biochar, rock dust, and microbes. The rock dust feeds the microbes live in the biochar in the surface area, and they exude nitrates, which feed the plants. We also produce biofuel. I don't know why that's not switching. Okay, this is 7,000 gallons of cellulosic biocrude made in a previous system that I was working with. This was made from soybeans. These are 2 test tubes of distillates produced from Virtro-type bio oils. What I did was I drilled 2 cavities in dry ice, inserted these tubes, let them sit there for 20 minutes, and then withdrew them. The test showed of these cloud points of minus 92 degrees Fahrenheit, whereas traditional biofuels usually have cloud points begin to turn solid at 32 degrees Fahrenheit. This is after we now pull the tubes out of the dry ice. See the viscosity. This is the future of jet fuel. We also produce Vertane biogas. We expect to produce 10,000 cubic feet of high-quality biogas per ton of woody biomass processed. Past tests indicate heating values exceeding that of natural gas. We plan to use the biogas to generate electricity to run the system, and to use giant reed to grow biomass. So essentially, because it's self-sustaining, we can, as I said before, produce energy anywhere on the planet. And when you think about what that can do to the planet, it's as important as when we developed fire, and that allowed us to create villages. If you watch the movie Quest for Fire, you'll see what I'm talking about. So both Ron and David, last week, David who spoke to us, are advocates for responsible engineering and technology that strengthens communities and the people who live there. That was the basic purpose of the CarbonStar system, even before it was developed. Let's discuss the socioeconomic implications and how to help create more resilient, sustainable economic communities. Our strategy is to help create sustainable local economic communities and investments by sharing CDR subsidy income from sequestration of CO2 while producing carbon neutral renewable fuels. The CarbonStar socioeconomic mission is what we have just described. It's the most important element to producing a truly sustainable economic system and planet. And as far as the carbon XPRIZE goes, it is a major component of that prize to determine how we can serve disenfranchised populations and communities with this new CDR industry. So let's look at the current economic system. The root cause of many socioeconomic and environmental problems is that the goal for investment in this current economic system is to attain maximum profits and maximum growth to benefit relatively few investors. When you really look at who's investing and making money, corporations are required by law to maximize profits and growth, or their investors can sue them. Profits and growth are not enough. Investors demand continually increasing profits and growth. If profits are up this year, the goal is to produce even more profits and growth next year ad infinitum. Investors also seek continued increase in the growth of the gross domestic product, the GDP. Now, the GDP is the total value of the final goods and services produced annually. In 2022, it was $25.46 trillion. An increase in the GDP indicates a healthy economy. Diminishing GDP means the economy is sluggish or in recession. More than 70%, I think it's actually 72% of the GDP is comprised of individuals' purchases of goods and services. In 2022, that was $18.4 trillion. So if consumers are buying, the economy is good. Consume, consume, consume. Let's grow this economy. If consumer confidence and purchases are down, the economy is sluggish or in recession. So let's ask why the quest for maximum profits and growth is not sustainable if we want to produce a sustainable economic system. Well, one, it requires continually increasing consumer purchases. This results in rampant consumerization, excessive resource consumption, pollution, and waste. Corporations must produce as many products as possible to continue profiting and growing. If there are no needs for products, they create the needs through aggressive advertising and marketing. This results in increased sales, which require more raw materials and resources and produce more waste and pollution. This requires corporations to maximize profits to sell at the highest price and make or buy at the lowest possible cost. Increasing prices contribute to inflation and unaffordability by many people. And some corporations now are using the inflation excuse to raise prices even more. Lowest cost, to achieve lowest cost, can usually mean lowest possible wages and benefits, layoffs in tough times, outsourcing, and minimum acceptable quality of product. Some of the stuff out there is just pure junk now, and some of it's really good. I think electronics have become better, but other products are really not. Planned obsolescence also helps maintain increased sales and profits. The current system also results in the concentration of wealth and opportunities into fewer and fewer hands. This is obvious when you look at the statistics. Now, a fraction of a percent of the population owns more wealth than the poorest 90% of the planet. And less than 1% owns 50% of all of the liquid wealth in the United States. The quest for continual increases in GDP and consumption drives consumers into increasing levels of debt. So to expand the economy, we need to expand consumer debt because they ran out of cash a long time ago. So let's look at this chart. Bill Clinton once boasted that between 1985 and 2001, the US economy grew faster than at any time in US history. Could this be a chart of economic growth? There you can see this increase between 85 and 2001. No, that is not a chart of increased economic growth. It's a chart of US household debt in trillions. So as the economy expanded, the debt expanded. We used to buy with cash, but then when the cash ran out, out came the credit cards so that we could mortgage our future to buy stuff today, a lot of which we don't need. This is a chart of total household debt in America since 1955. During those 16 years between 1985 and 2001, debt increased almost $5 trillion. Now let's look at a more current chart. Between 2001 and 2005, debt increased another $5 trillion in just 4 years, 4 times faster than the previous 16 years total. And that was just to barely hold the economy together, if you remember those days. Let's look at 2016. This is a hockey stick of hyperbolic growth in debt. Not only is this difficult for families, it's how you control a populace. We live under an economic system that must continually and increasingly indebt the populace in order to be considered healthy. Does anybody think this is sustainable? I've asked a lot of people, no one has ever said this is sustainable. Then if it's not sustainable, I've asked, how must it end? What does that look like? Some people said economic collapse, others revolution, others authoritarian, dystopian society, war. Others said, I don't care, I'll be dead by then. Now here's what one well-known person said: more than in any other time in history, mankind faces a crossroads. One path leads to despair and utter hopelessness, the other to total extinction. Let us pray we have the wisdom to choose correctly. And that was Woody Allen. It was funny 20 years ago when I first put this up. It's actually becoming closer to the truth. So what we need to do is we need to create sustainable economies. And in a sustainable economy, no one goes hungry. There's affordable housing for everybody, living wage jobs for those who can work, medical care, education, opportunities to improve one's life, sustainable living on a clean planet, a more leisurely lifetime, and time for spiritual renewal. In a sustainable economic system, the goal for investment is not max profit and growth for a handful of elites. It is to produce adequate profits, sustainable growth for the good of all. Now, adequate profits at some points in a company can be break even. Thank God we stayed alive. I've been in that situation before. And sustainable growth could also be same as last year, no growth, but survival. So, and keeping the employees employed. So we must find an investor with enormous wealth and a long-term vision who would accept this goal. To be effective, these new investors must always be there with no need to change their minds. They have to be in for the long haul. We need them to provide billions of dollars on a continual basis. This investment paradigm must be woven into the fabric of society so it is entrenched, never to be removed. Who's such an investor? Philanthropists, yes, on an individual basis, on occasion, but there's not enough of them. There is one investor, however, who meets the above requirements and will accept adequate profit and sustainable growth for the good of all. In fact, the most selfish interests of this potential investor demand that these new criteria be met to avoid grave misfortune. That investor is the community itself. You can see what's happening to the current economic system as we speak. It is unraveling. It's been unraveling for years. The government has been able to prop it up. We're using different techniques. The last one, handing out $7 trillion to everybody to keep them buying. And so the new investor is the community. How can the community as an entity become an investor? We have to be able to create funds for the community to invest. In 1998, going back to neon technology, investors began abandoning Asia for better returns in other locations, causing the demise of the Asian economy. Neon Technologies' Tokyo-based company partner joint venture fell on hard times, resulting in the dissolution of our joint venture. I had to close my factory door on August 30th of 1999 after finding jobs for all of my employees in other companies. Over the next 4 months, I had an epiphany of sorts. You might say it was a vision that introduced itself gradually. In December of 1999, I was finally able to articulate what was coming through. It was a sustainable economic system that also serves the common good. To describe my vision, I put the pen to paper at 11 a.m. on January 1st of 2000, the first day of the new millennium. Thus, I gave it the designation E2M, an economic model for Millennium 2000, and created the domain name e2m.org as the home for this sustainable economic model. Now, what does E2M do? Understand, it's an infrastructure. It's a structure, a way of doing things. It now needs to be populated. But what it does is it is a community-driven, voluntary, free market system. It doesn't try to kill the current system. The current system is killing itself anyway. Why would you kill someone who's committing suicide? So E2M is a free market system that operates parallel to the current system, interacting with the good parts of the current system, but rejecting its mission, its selfish mission of max profit and growth for the few in return for adequate profit and sustainable growth for the good of all. So we create the infrastructure that enables communities in partnership with businesses and entrepreneurs to use the tool of capitalism, the most powerful wealth-creating tool in the history of mankind, to create enormous amounts of citizen-controlled community wealth, just as individuals and corporations have been doing for hundreds of years. And here's how the model works. This is the E2M model. It stands on 3 pillars: the Regional Economic Council, the affiliated businesses, and the community itself. The Regional Council does community initiatives with its income. Community members sit on the Regional Council. That's that relationship. E2M businesses donate a portion of their profits or equity to the council, and the council in turn provides low interest loans as low as 0% and friendly startup venture capital for new startups, in which case the community would own larger percentages, 40 to 50% of these new startups. The E2M businesses, the way they link to the community is the employees determine where 50% of the company's donations go to help the community. So the employees of a particular company may say, we want to help that young girl have her her lung transplant. This happened in our area. And so her project is to help her stay alive. So on a bad day at work, when they're coming in and they wish they weren't working there, her picture is up there, and they understand we're working for more than just a paycheck and more to make the company profit. We are working to help this girl stay alive. This is how you introduce soul into the corporate entity. And the return is that the community members will pledge to purchase from E2M designated businesses by simply purchasing goods and services they already need and buy from these companies. They look for the E2M logo on products or can go to a future Amazon type website to purchase from E2M companies. Community members can guarantee that these businesses will grow and provide a steady flow of revenue to the community. Community members in 22 spent $18 trillion. This could support 18 million businesses doing $1 million a year each. Even if a fraction of 18 million businesses were E2M certified, they would create enormous community wealth that could be used to make a huge difference in our society. Now, of the money that the regional council gets, which is 50% of the corporate donation, 75% stays local, 20% goes national to help link to other regional councils and to help form them or to support them when times are tough in a particular area like the Rust Belt. And 5% goes to international. Not that $50 to Kenya is going to make a big deal, but it's going to create relationships between people. And on those relationships, the model can continue to grow. So as the community develops income from this model, what can these community investments do? They can make the loans to the businesses we talked about. They could establish inner city organic farms paying living wages and benefits and profit share to local residents as young as 13. Give them jobs, give them a future. It could hire and train inner city residents to rehab properties. They could provide 50-year mortgages so that a house, $200,000 house costs $400 per month instead of $1,200. Could produce city condos for $50 a week, purchase commercial realty. I'm almost at the end here. And provide stable rents to small local businesses for decades. They could partner with public research universities to develop technologies to achieve maximum solutions rather than maximum benefits. And you folks in particular know how important technology is to the direction of society. And as it is now, with wealth so concentrated and these grantors so concentrated, they control the direction of society. Communities now need to begin to control the direction of society. And these councils can act collectively with other regional and national or global E2M communities to work on major environmental, social, or economic initiatives. Back in 2012, John Oliver, who was our congressman, said, during the past 8 years, I've watched E2M grow from an idea into a new voluntary economic option for our region. These efforts have my support, and I'm excited to see how they can grow. The board back then said, okay, we've done all the work we need to produce a templatable regional economy. Do we knock on doors to businesses? We did some of that, but what we finally concluded was, no, let's create an industrial base to help populate each of these regional economic models. And that industrial base included renewable fuels, powering indoor farms, producing food. This is how the CarbonStar technology came about, to satisfy the need for that fuel. Even Bill Gates says we need a new form of creative capitalism that balances the needs of the market with the needs of those the market leaves behind, at the 2008 World Economic Forum. If you want to read more about it, I wrote a book. I call it Community Capitalism. One, because it is capitalism, but the capitalists were calling me a socialist and the socialists were calling me a communist. So I wrote this book to keep the record straight, and it's available at communitycapitalism.com. You don't have to buy it. You can read it free. I'm not trying to sell books. So CarbonStar, at this time, we've completed construction of the prototype. We have the technology we need to create long-term CDR operations. We understand how we can connect engineering and technology to benefit all stakeholders in the community. And in answer to Tom Hoppett's question of January 28th, 22, Tom, at Hugh's presentation, we are preparing to shout about what we can do. We are now preparing our stage. At this moment, as we speak, riggers are moving the CarbonStar system and facility from its birthplace to its new home. This is one of the rooms of the facility that we're going to operate the system in. It is here we will also produce the next generation of the CarbonStar system. It will be fully containerized, able to be shipped by truck, rail, or even deployed by heavy lift aircraft to any suitable location in the world that requires carbon negative energy and fuels. And this is our adjacent room. It's a 1/4-acre room with 3 overhead 30-ton cranes where we plan to mass produce containerized CarbonStar systems. These systems could go to communities to produce power they can purchase as part of the community choice aggregation that David spoke about last week. They can help link the energy sector, the most important sector after food and water, to the social sector. By using funds from the energy sector to ensure the health of the social sector, we can establish long-term sustainability based on income from tangible, perpetual income-producing assets rather than fickle stock markets, shiny metals, or devalued pieces of paper. They can also help inspire other businesses and communities and people to join the local E2M economic community, to form other regional E2M communities around the country and beyond, to help create a better, sustainable, more hopeful world for us all. Thank you.
Michael, I want to thank you for that. You've given us a remarkable demonstration of what it means to be a technical, an economic, a social, a commercial entrepreneur. I don't think I've ever heard such a comprehensive position statement focused on technology with so many tentacles. It's really quite impressive. I have a couple of thoughts, and I'm sure there are questions, but I want to make a couple of suggestions, and I have a question. First of all, I think when you were talking about E2M, that just sounds like a very ripe, something that would be very ripe for collaboration between someone like yourself and David Zhu at MIT. We heard from David last time when he spoke about community activism. I think there might well be a useful and meaningful collaboration. Secondly, I was really happy to see that John Oliver was interested in this and knew about it. And I have to ask, have you had any follow-on interest from the perspective of people in political life who might just be able to breathe some movement into what you're talking about with E2M? Just curious.
Well, actually, in 2008, when the board said, let's develop an industrial base, we said, okay, we know we can get political support because I had John Oliver's people on my board. I had Stanley Rosenberg. He was president of the Senate. He had Mary Jane on the board. Ben Swan from Springfield, a legendary civil rights activist, sat on the board. I had economics professors, economists sitting on the board. So we had a lot of buy-in. I spoke at national economic conferences where the response was tremendous. So at that point, the focus became the technology. And sometimes these things take longer than you want. So the technology is really just being developed. I will begin to have conversations. My former board members now, John Najelski, he was working with John Oliver. He was his district director. He's now district director for Jim. Oh boy, Jim is our local congressman. So I forgot his last name. McGovern, Jim McGovern, yeah, Jim. And I spoke quickly to Senator Markey. He said I'd be interested in knowing more. So we haven't followed up with the politicians again yet. Once we get this facility going and we can walk them through and they can see where we're headed, I think we're going to begin to reconnect. We will be reconnecting with them.
Very good.
But understand this does not require approval of politicians. It doesn't.
No, I know. In fact, I was about to suggest you ought to send your book to people like Bill Gates and Elon Musk and see whether or not you get any reaction from them. But I want to turn before I see Eddie's hand up. I just want to ask you one more technical question. You mentioned that decaying biomass produces 17 times more carbon dioxide than all other sources.
Yes,
That's something I really I had never heard.
it's a surprise. If you Google NASA carbon cycle, you'll see a chart that shows where all of the CO2
Well,
is
Michael,
coming
what
from.
are the oil companies not responding to that by saying, look, we're not the major problem, or the energy companies that are using coal? Why are they not responding to that?
One, because they're complicit. So even though the biomass produces more, it's the coal that's producing and the oil that's producing a significant amount. So I don't think they can say, well, that guy's worse than we are, so don't look at us. And also, transportation is the most easily identified emitter. So that's why you see a lot of the discussion going towards transportation. And in fact, Massachusetts is an anti-biomass state. They don't want me doing this. The governor wants to stop all maintenance of forests in state-owned lands.
Yeah.
So there's a strong anti-biomass contingent in the state of
I wasn't aware of
Massachusetts.
that, but I mean, I just think about the numbers. You know, if there is a 17-fold difference, then automobile emissions can't amount to that. It can't be that significant, nor coal emissions from coal burning fossil thing. And yet they're not. There's no conversation.
No, you're right. They're not compared to biomass.
Yeah.
I can sequester more CO2 in a few hours than a tree can in its entire life. And I can sequester it permanently. The tree is temporary. I can sequester in 4 days more CO2 than 1 acre of 50-year-old mature forest can do in a year. But I only need 2 or 3 trees out of that acre to do it. Do you think they want me to get those trees? Not in Massachusetts. Everywhere else in the world, yes, except for Massachusetts.
Well, let's take a couple of questions so we don't run out of time. Eddie, you had your hand up.
Yes, I was intrigued by your E2M economic model because it reminded me very much of another model, the Mondragon model, which was very successful in Spain, even though it was under the control, not control, but in the environment of Franco. That was actually very successful. I don't know what its state is today, but that was one thing. So, so to me, what you're proposing is nothing new in that sense. But the question I have as well with regard to the technology, and maybe I'm trying to understand this, you're producing biofuels which eventually will burn anyway. Is that correct?
Well, that's one use. If you burn them, then they're carbon neutral. But if you use the oils in asphalt to make roadways or other uses where you use oils, then it becomes sequestered CO2.
Right. Now, the other question, well, the other point is that in the natural world, let us say, the CO2 is recycled in the sense that it provides basically things die in the forest and other things grow. So in a sense, at least there used to be a balance. So when you take it and you do it, so that's how you basically claim it's essentially carbon neutral. Is that correct?
Yeah, it's carbon neutral because when we pull the biomass has already absorbed CO2 from the atmosphere that used to be there as CO2. So if we burn it, it returns that CO2 to the atmosphere. But if we interrupt the natural carbon cycle, we keep that and sequester it and reduce the CO2 in the atmosphere. Do you understand?
It just seems to me yes, it seems to me like you're accelerating the process in some respects.
Accelerating the
carbon cycle process.
We're actually interrupting it. We're interrupting that portion where the decaying biomass reintroduces the CO2 or methane into the atmosphere.
Right. Okay.
Okay. Let's see, Hugh, you had your hand up. Where is Hugh?
I'm here. I got a little trouble with my video, so I shut it
Oh,
off.
okay.
I
ahead.
want to thank Michael for a fabulous presentation. I think it's a really important
I
development.
agree. Yeah.
And it is I like to think of it as a black box that you, on one end, you put in biomass, which is has already been created, and I think is highlighting the fact that there is enormous feedstock represented by the factor of 17 times more biomass created than we're currently consuming. So there's plenty of feedstock. And you put that biomass into a black box, some portion of it gets permanently stabilized and sequestered, some portion may get re-emitted. But if you hadn't put it into that black box, all of it would have, over a period of a few decades, reverted to CO2. So it's a net negative that's very important. And I also found this admirable social conscience that comes to play in a lot of his talk is attractive. I think it shouldn't, we shouldn't let it detract from the impressive technological accomplishments. That's my thoughts. Thank you.
Good,
Thank you, Hugh.
thank you.
And
John?
Hugh's right. I talked to Hugh about whether I should even bring up the economic component. He said, look, we don't want to distract from the technology. The technology is very important. So that's why I put the social component last.
Well, you know, and frankly, I think that's important. I mean, technology is intended to serve society. And, you know, you've made a very elaborate case for it, more elaborate than I would have imagined most technologists would be able to do. But I think it's a useful construct. So I appreciate that. Let's go to John.
Yeah, I would say this was all very interesting. It was really too much for one talk.
Yeah.
I don't know whether
Yeah.
in the future we could have it broken down. I think we could have at least 1 hour on the technical carbon sequestration part, and then at least 1 hour on the social economic, although I don't know if that's beyond the scope of our group on that side. I was just wondering, what do we know about the real stability of biochar in terms of permanent carbon sequestration? You know, it's not like you're putting it down and burying it, 2 miles under the earth. If you use it for fertilizer enhancement or whatever, you're putting it down with your crops in the soil, it's getting weathered, exposed to oxygen, et cetera, et cetera. How do we know that 100 years from now that biochar carbon is still just hanging around in the topsoil, as opposed to some various slow chemical reactions where it winds up in the atmosphere?
It's a great question, and you're not the only person asking that question. It's very important, and much work has been done on that. So initially, we found biochar first used 7,000 years ago in the Amazon. And if you Google The Secret of El Dorado, there's a couple of videos, but the one that's an hour and 1 minute long that begins with an airplane propeller, you're looking at the front of the airplane, so you Google that, and that'll show you how they use biochar to replenish soils in the Amazon to actually go from hunter-gatherer to established agricultural populations of hundreds of thousands of people. Also now we're doing very significant studies. It will stay in the soil for thousands of years. There is some degradation. It's less than a couple of % per year, but that's all been quantified at this point, John, because it's a really important question. Thank you for bringing it up. And thank you for the article from the Wall Street Journal.
I just, before we close, and it's almost noon, I just wanted to ask Marilyn or Peg if they have any questions that you'd like to address to Michael. Go ahead, Marilyn.
I do. I don't understand the chemistry of how dead biomass can take CO2 out of the atmosphere.
The dead biomass doesn't take it out, it emits it. So when the bacteria are consuming the hydrocarbons from the rotting biomass, they emit CO2.
So I didn't explain my question fully then. It's how your procedure using biomass to fix CO2.
The tree absorbs CO2, gives off oxygen, keeps the carbon. A tree is 40 to 50% carbon, depending on the species. When that tree dies, that 40 to 50% carbon through microbial activity turns into CO2 again, or methane, and goes back into the atmosphere. And that's how the carbon cycle works. Again, Google
Right.
NASA carbon cycle. We interrupt the rotting process by carbonizing the dead wood and permanently sequestering that carbon that it contains. Did I say
So
that?
the-
Okay?
It's getting closer. So you're
Michael, do you have?
capturing the carbon in the dead, in the wood, and then you carbonize it with heat. But how does that take up more carbon out of the atmosphere?
It's not, it's removing carbon from the atmosphere in a sense by preventing it from going back. The tree
Yeah,
is actually removing it. We're preventing it
what-
from going back.
What's
I think
happening?
I think the confusion is, which I am a bit confused about. A tree dies, emits CO2 into the atmosphere, but then it is, by natural cycles, it nourishes the ground, which builds another tree. And so you take the carbon back out. So over a large area, and statistically, it becomes carbon neutral. So what you're doing is interrupting and taking that tree out, and then carbonizing it, and then putting the soil back to nurture more carbon, more plant growing carbon, if you will. So the cycle is, so to me, you're not necessarily interrupting it, you're just changing the channel.
But that's an interesting point. I hadn't thought about that, but you can
That's
look
how
at that.
I understand it now. That's
Well,
what, that was my question too. And that's
Yeah.
what I think Marilyn is confused with.
No,
Am I
I
right,
think-
Marilyn?
I think what Marilyn raises it's a very interesting question. Let's take it as maybe a more direct example, the blob in Florida, the seaweed mass. How would you treat that? And what is the chemistry, or how would you answer Marilyn's question in terms of, for example, the seaweed that is
Well, the seaweed, algae is the fastest growing substance, plant life on the planet. And so the seaweed is absorbing carbon from the ocean.
Okay.
And we're doing the same thing. We're turning that seaweed into carbon, solid carbon,
Yeah.
and burying it or mixing it with cement or in highways.
Yeah.
So we're sequestering the ocean's carbon the same way we're sequestering atmospheric carbon, only we're using seaweed as the so-called a transition agent, if you will, that pulls the carbon from the ocean so that we can actually take that carbon and sequester it.
So in this case, the seaweed is actually the source of carbon that you're sequestering.
Correct.
Yes. Marilyn, does that help a little?
Yeah, it's really not a direct process.
Yeah.
Of magic going on inside your big vacuum tube, taking CO2 and jamming it into biomass somehow. It's you're taking the biomass that's already produced and just keeping the carbon from escaping again.
Exactly correct.
Yeah, but Michael, in a sense, what you're doing is taking carbon from the oceans and transferring it to land.
So correct,
sequestered.
we're taking the carbon out of the ocean, which will transfer it to the land. Now the ocean will absorb some more from the atmosphere as a result of that, and we will take that. So that's why we're taking it from both sides.
True.
We want to take it from the ocean and the atmosphere.
But the important point
That's-
is that once you process it, Michael, it's sequestered. It won't go
It's
back.
done.
And
It won't
that,
go
so
back.
there is a net removal of carbon from the atmosphere, carbon dioxide from the atmosphere.
Yes.
John, you'll have the last question today, John. Go
Well,
ahead.
actually, it wasn't
Sorry.
actually, it was just really a response or to what we've just been talking about that I was going to say that what this potentially is a nature enhanced, very efficient way of taking carbon out of the carbon cycle. Because once the CO2 goes up the smokestack and it's in the atmosphere, as there are hundreds of trillions of tons or whatever we're saying that needs to be removed from there, you've got this problem. And I mean, a lot of people are, corporations are working on this to take that carbon dioxide out of the air where its concentration is 0.04%.
Correct.
You got to have huge fans to get a little bit of carbon out of air where it's 0.04%. And then they're taking that and making it into concentrated CO2, which they then have to pipe across to another part of the country where there's a lot of resistance to those pipes, by the way,
There is.
a lot of problems with those pipes, and then put it down underground a couple of miles to sequester it. And the government is now going to subsidize that up to like $600 a ton or something.
Correct.
Here, you've got nature working for you, taking that carbon out. You got that sargassum weed that's absorbing this excess carbon and making it into, this stuff, this nasty sargassum weed, but it's who knows what, 20% carbon or something like that. And all you have to do is take that stuff and then you put it through Michael's machine. And in the end, one of your major products is the biochar, which is a solid thing, not a, another gaseous form of CO2, which you can do a lot of interesting and useful things with. So it is theoretically vastly more efficient than what a lot of the big corporations are working on and getting subsidized.
You're exactly right. In fact, the article that you sent begins saying, forget all of these fancy technologies we're talking about. Here's a simple one that does a much better job. And when you consider the energy that you need, you just pointed out, 1 million cubic feet produces 420 cubic feet of CO2, which is about 40 pounds. And so you got to compress it. It's I hate to say it on a recorded thing, but I think some people think it's laughable.
Michael, I just want to say I think it's just very clear you have a very deep social conscience, but it's driven by technology, which I just love. I think that's a very, very good combination. And I want to thank everybody for being a part of this conversation today. I hope our friends from Bethlehem will rejoin us whenever you feel inclined. I'm glad you were here today, and Marilyn and Peg and John, thanks for introducing them to us. Please come back. You're welcome anytime. Let's call it a day for today. Michael, thanks again. It's wonderful
Thank you.
talk. I appreciate hearing all that.
Thank you, everybody.
Okay,
Thank you,
everyone.
Michael.
Yeah,
Thank
take
you
care,
so
guys.
much.
Have a
Thank
good
you
weekend.
for accepting me as a part of your group. As a lone inventor, I kind of feel it's kind of unusual that I'm here. It's kind of a stroke of luck, and thank you for embracing me. I'm honored. I'm truly, truly honored.
Thanks, Michael. Take care. Have a great weekend, folks. Bye-bye.
Thank you. Goodbye, everybody.